Okay, we will study quadratic function transformation today. A value at outside with a plus minus, those value will be vertical stretch or shrink or reflecting over x-axis. So if it is a negative, that reflect all functions over x-axis. And then the value of a, it depends on if a is greater than 1 or less than 1. Either vertical stretch or vertical shrink. And then we'll say about the b value inside the parenthesis here will be, if it's a negative, that value reflect whole function over y-axis. And then the b value, it depends on b value. b is greater than 1, then it will be horizontal shrink by 1 over b. And if it's a less than 1, greater than 0, for example, b is 1/2, then it will be horizontal stretch by 1 over b. Horizontal stretch by 2, that's what we say. So if it is a less than 1 for the v value, we will say horizontal stretch by 1 over b. That's what we say. And then x minus h represent it move to the right left. So h is a positive, then move h to the right. And if h is a less than 0, then move h to the left. And then very outside number plus k, the k value is representing moving up or down. So if k value is a greater than 0, move up, move k value up, or k value is less than 0, then we say it will be move up k amount, move down. And then the blue one here, the very outside the value plus minus or a value, and then plus k very outside to the right, all affect to the y value. So you have to change y value according to the transformation rule. And then orange color here inside the parenthesis representing translation or transformation for x value. So follow by the rule, you have to change x value for those inside the parenthesis. And by this rule, we'll try to graph those functions. And then first, we will start with the parent function. Y equal to x squared is a parent function for the quadratic. And if I draw a table for quadratic function, -2, -1, 0, 1, 2 as an x value, then y value will be 4, 1, 0, 1, 4. And outside -3 representing reflect over x-axis, and then vertical stretch by 3. And then very outside number here, it move up by 4. Those are representing changing in y value. So we have to find the new y value as a, you have to multiply by negative 3 into the y value, and you have to add 4 since it moved up. So you need to multiply by negative 3 to the y value and then move up 4. That's a new y value. And then inside here, x minus 2 representing move 2 units to the right. This value represents changing in x value. So you have to add 2 to the x value. So x plus 2. So x plus 2 will be 0, 1, 2, 3, 4. And then new y value will be negative 8, 1, 4, 1, negative 8. So originally parent function of quadratic function vertex at 0, 0. So if I graph it here as a parent function first, 0, 0, and 1, 1, 2, 4, then negative 1, 1, negative 2, 4. The graph usually open upward U shape, and now it moved because of transformation. The vertex become a 2 and 4. It moved 2, 4. So the vertex 2, 4. And axis of symmetry for the quadratic function happens in x value for the vertex. So x equal to 2. And the graph, since the graph is open upward, our new graph, negative 3, it's a reflect over x-axis. So we will graph it, it will be open downward. The 2, 4 as a vertex here. And then 1, 1, 0, negative 8. And then with the axis of symmetry here, you can just find the reflecting points here. And then here, the new graph looks like this, open downward, like that. So original parent function of quadratic has a 0, 0 as a vertex and open upward will have a minimum value, but new function will, because of negative value for the a, it will be open downward, it will have a maximum value. Maximum value as a vertex y value, which is a 4, open down. And domain for quadratic function, always all real number. Remember that. It will be always all real number. And range for this new function has a maximum as a 4. So I can say y will be less than or equal to 4 as a inequality, or you can express as a interval notation for range will be negative infinity to 4 included. That's how you can express. And when you see the graph is increasing here, increasing this direction when x is negative infinity up to 2. So increasing graph happens from negative infinity to 2. And then the graph is decreasing here when x is from 2 to infinity. So you can say the graph is decreasing from 2 to infinity. So when you write the interval when the graph is increasing or decreasing, you have to express what x value when the y value increasing or y value decreasing. So remember that. And then we will go to the next problem here. Also, we will start with the y equal to x squared quadratic function parent function x and y, -2, -1, 0, 1, 2 with a 4, 1, 0, 1, 4. And then I will graph it 0, 0, -1, -2, 4, 1, 1, 2, 4. Then the graph looks like open upward U shape. And then when you see first 2 here will be inside the parenthesis. It wasn't outside. It was a parenthesis to the square here. It's inside. So inside value is a horizontal. And this is a 2. 2 value for the b that we have to think as a 1 over b, which is 1 over 2. So this is a 1 over 2 means it becomes a smaller. So we say that as a horizontal shrink by 1/2. And then x plus 1, you have to think as opposite sign because we express as a x minus h. So x plus 1 means move left 1. So one value. And then outside, very outside, -3 will be move down 3. So if we express because of horizontal shrink by 1/2, those value and then move left 1, these two representing affect to the x value, new x value we need to find, and move down 3 will be translation to the up or down. Down means y value changing, so we have to find the new y value for that. And then horizontal shrink by 1/2 means we need to multiply by 1/2 to the x, and move left 1 means -1. So new x value we can find by multiplying 1/2 to the x and then -1. And new y value we can find by subtracting 3. So y minus 3. That's how we find the new x value and new y value. And -2, because 1/2 times -2 minus 1 will be -1 minus 1, so it's -2. And then 1/2 times -1 minus 1 will be -1 over 2 minus 1, so -1.5. And then 1/2 times 0 minus 1 will be -1. And 1/2 times 1 minus 1 will be 1/2 minus 1, -1 over 2. And 1/2 times 2 minus 1 will be 1 minus 1, which is a 0. And then y minus 3. So 4 minus 3, 1. 1 minus 3, -2. 0 minus 3, -3. 1 minus 3, -2. 4 minus 3, 1. And parent functions, vertex was a 0, 0. Change it to the -1, -3. So -1, -3 here. And then it move -1/2 with a -2 here, then here. And then 0, 1. Graph looks like this. So horizontal shrink by 1/2, and then move left 1, down 3. So new vertex was -1, -3, and axis of symmetry happens with the x value for the vertex. So x equal to -1. You have to express axis of symmetry as an equation. Since the graph is open upward, the graph has a minimum value. And domain for the quadratic will be always all real number, -infinity to infinity. And range will be, since this graph has a minimum as a -3, So I will say y is a greater than or equal to negative 3, or as an interval notation for range, negative 3 as a least value, smallest value to the infinity. Negative 3 is included using bracket. The graph is increasing. Now, when you see the graph is increasing here on the right side from the axis of symmetry. So I can say the x value while the graph is increasing happens will be from negative 1 to the right side, which is a greater infinity. And then decreasing, the graph is decreasing here like that on the left side of the axis of symmetry. So the graph is decreasing when x is from negative infinity all the way to negative 1. That's how you can say. So I will upload some video about related to the quadratic function from SAT problem next time.